Yes. So in the last time we have started the discussion about the GIS data input. In that one, you have learned about the two different methods. First one was key coding or keyboard entry. Okay, I go to the start. So this one was the complete data stream diagram, that how the data got collected. It will start from the map, satellite images, digital data. These are the different sources. Then by using the different capturing methods like keyboard entry, digitization, scanning, data transfer, the data will get captured. After that, it will get edited, means cleaning, then reprojection, generalization, edge matching and rubber sheeting, layering. And finally, integrated GIS database will be created from this one. This whole procedure, the way in which the raw data is finally entered inside the integrated GIS database, this is called data streaming. Okay. So we were going through the very means second step. We have already learned about the sources. We are going through the data capturing step. In data capturing, first one, the keyboard entry. Usually the attribute data got entered through the keyboard, and still many times when we got the information in the form of paper, like if you go to some medical office or anywhere else, you will obtain the detail in the form of hard copy. So in that case, you have to enter all that details manually inside the system. So as I have shown you previously that the attribute table need to be built, and in that attribute table you have to manually enter all the records. Another option is that if the data is available in the digital form, like the Survey of India census data, it comes in the Excel sheet form. In that case, you can easily perform the join operation over there. Okay. Next one was raster
Ma'am,
data capture. Yes.
which join we perform?
Sorry.
Which type of join we perform? Natural join or conditional join or
No, no, no. The join that you are talking about is in database. In DBMS, we have these options. In this one, there is only one join. Okay. I will show you this thing. There is one simple join. The join that you were telling. Just wait. So there is only one option. As you can see on the screen, there is only one option of join over here. Okay. So there's nothing like natural join and all the different type of joins of the DBMS. You do not have to do that thing. There is only one join, and this join operation is performed with the help of a common key. Okay. Like suppose in this case, this one is the school data. So I have school code. With the help of that school code, which is a unique ID for every school, just like student, every student will have a unique enrollment number. With the help of that one, any of the information will get joined with the help of that particular field. So here also you need to select one of the field and join operation will get performed. In raster, we have discussed that there are two main sources. First one is the images. There can be satellite images, there can be aerial photographs. Nowadays, everything got captured in the digital format. Therefore, there is no need to perform any conversion operation over here. Most of the data, like satellite data, is completely digital. Even the aerial photographs nowadays is completely digital. But yes, if you have the historical data, if you have an historical image, in that case, you may need it may be in the hard copy form, in the paper format, and later on that need to be converted into the digital form. The most important source of data in GIS is map that we have earlier discussed in detail. So when we talk about the map, there are different places from which the map could be obtained. Like there can be a Survey of India map, there can be USGS maps. So these maps are in the paper form. Okay. So for the conversion of a paper map into a digital format, what we need to do, we need to perform the scanning operation. Okay. So as you know, in any of the scanner, there are the typical component that there will be a glass sheet, there will be a light source. Whatever light falls on the document, it will get reflected back. Then there will be photosensitive sensors, which are CCD, charge coupled devices. They will take the photon and convert them into the electron. That is, light will get converted into the electrical signals, and with the help of that, scanning operation will get performed. In GIS, we will have three types of scanner. First one is the flatbed scanner, second one is the rotating drum scanner, and third one is the feed forward scanner. Okay. So flatbed scanners are mostly used in the offices, and means in GIS, you cannot scan a large size map with the help of these flatbed scanners. Yes, when we get something in hard copy form, like earlier I was telling you that the attribute may have been collected from the field in a hard copy form. In that case, these flatbed scanners can be useful. But if you have a large sized map that need to be scanned with the help of a drum scanner or the flatbed scanner. So these drum scanners are basically, there will be a very large drum, as you can see on the screen, that there will be a drum and the map will be folded around this cylinder or around this drum. Okay. After that, the document will remain static, but there will be a sensor that will move and collect the data from here. This type of scanner are most expensive, most precise, most accurate, but they are very slow. Okay. Another option is we can go for the feed forward scanner. As you can see on the screen, these are the feed scanners. In this one, the page will get inserted, just like you can think of printer, when you see any of the printer or photocopier machine, the page will be moved. Okay. So in this case, the sensor will remain static, but the map will be dynamic. It will move in the forward direction. This type of feed format scanners are comparatively slow in speed. Okay, their speed is faster, and their cost is comparatively low. Okay, most of the time we go for the feed forward scanner, and this is how the scanning operation has been done. If we see the parameters that we need to consider while scanning, first one was mode, means color mode. It can be grayscale, it can be black and white, or it can be colored. In GIS nowadays, majority of maps are in colored form. Therefore, color mode is preferred. Another thing was resolution. So we have image resolution, which is measured in DPI, dots per inch, and the relation of cell dimension and cell volume, it is true over here also. As you increase the DPI, the quality of image will be better, the precision will be more, but the size will also be large. If you go for the lower DPI, the size will be less, but the image quality will also not very good. Okay. Then georeferencing and vectorization we have already discussed, and later on we will discuss it again. So when we are going to the next step, which is the vector data input, the vectorization operation will be performed over there. Thereafter, we have seen the problems that are associated with the scanning. One problem is about the source map. Okay. If there is any problem in the source map, the quality will automatically get affected. Why? Because if there is any sort of staining, any sort of marking, fold mark, wrinkle, pen mark, pencil mark, anything like that, it will automatically get appeared on the scanned output. Okay. Then the dust particle is may create problem because the light will get scattered from that one. Another problem is how we are inserting the document. Okay, so if the document is not properly inserted, in that case it will get skewed. Now we have to start from here. Vector data capturing. Vector data could get captured with the help of GPS. This nowadays, this one is a very common one, that you will go to the field, take the GPS receiver. Whether you want to collect the point data, line data, polygon data, whatever you want, you can collect it with the help of GPS. We are not going into the detail of GPS. We are more focused on the second part, how the digitizing process is used. Okay. Now, if we see the digitizing, first of all, I think so. I have already read this portion. So in the digitizing, there will be a digitizing table as it is shown on the screen. And the position of the operator is in the downward direction. That's why it is called heads down digitization. Just like other digitization, here also first step is the registration. First, the whole digitizing table need to be registered according to the map. And thereafter, the digitization of point, line, and polygon is done. Finally, attribute data is added with them. What we used to do heads up digitization or on screen digitization. Majority of digitization that took place nowadays is in this form only. Okay, so the digitizing, like all of you have learned this process in laboratory sessions. Here also you have done the heads up digitization. There is an extra step of scanning because you will not perform this process on a hard copy map. It will involve one step more, which is the scanning of document. In the previous one where there is heads down digitization, in that case, the paper map is used and that is done with the help of a digitizing table. Since we are doing this heads up digitization on the computer screen, that's why there is one extra step of scanning. Okay. Now let's see how the digitizing is done and why we used to do this digitizing. As you can see on the screen that there is one map. Okay, there is a map on the screen and there are roads over here. Is it okay? So on the screen there is a raster map, Survey of India map, sheet number P15. This one is covering the Allahabad city region. And now on this map you can find a road. Okay, with a red color line there is a road over here. Now if you want to perform any analysis, like suppose there is some government policy that they are trying to develop the region which lies within 200 meter from the road, can you perform this analysis right now? The answer is yes, you can perform it, but it will be complete manual process. From every point of the road, you have to measure 250 meter and then you can draw a polygon around it. It will be a very, very difficult task. Now see how what we can do on the GIS. Like suppose this one is the NYC street data, New York City street data. Zoom in just to a part. Now I want to identify all that region which falls within 200 meter from this road. I will select input features NYC street. I am entering 200 meter over here and clicking OK. Just wait for a minute. It will take some time. As you can see, buffering operation is going on. I have just pressed few of the buttons. And now after that, you can see the output. Okay. On the screen, you can find the 200 meter that falls around the road. Such a simple one-step process is done when we have a vector data. Now, if I want to perform the same operation on this map, can I do this thing? The answer is no. Why? Because the road is just drawn on the map. It is not extracted from the map. There is a drawing, it is portrayed on the map, but you cannot extract or you cannot do any analysis on whatever features that are drawn on the map. That's why we need to perform the digitization. If I do digitization, what will happen? the road will get extracted like this. Okay. Yes. Now on the screen you can find that there is a road which is going across the whole Allahabad city. And now if I want to perform any analysis, I can do this thing. How this whole digitizing took place? So there are three types of entity broadly. Okay. What are these three spatial entities? These are point, line, and polygon. Okay. So we have three different entities, point, line, and polygon. On the map, everything that you can see can be categorized under these three categories. Okay. Now, first I will give you one of the example, like, if I want to do some sort of embroidery on a tablecloth, what I will do? I will take the cloth, I will take some thread. Will I start the embroidery immediately? The answer is no. First of all, I need a design on that cloth. Only after that I could do any type of embroidery on that one. So what will I do? I will take a design, I will take a carbon paper, and I will take the cloth. Then I will first place the cloth, then carbon paper, then the design, and then I will take one pen and start tracing the design. I will start pressing all those places, place my pencil or the pen at all those places where there is a design. So basically what I am doing tracing operation over there. When I will perform this tracing operation, automatically that design will get printed on the cloth. And thereafter I will do all that thread work on the tablecloth. Okay. So this is one of the very basic example. आप डे टू डे लाइफ में इसको देखते हैं, कोई ना कोई चीज ट्रेस करना है। अगर आपको कोई डिजाइन किसी भी चीज पे चाहिए, आप पहले बेस जिस पे भी चाहिए,
मैम
जिस पे भी
वॉइस
आपको, ओके, इसमें ऑडियो ओके ना? आवाज ठीक आ रही है?
यस मैम।
Yes, ma'am. Yes, ma'am.
अगर कोई प्रॉब्लम आए तो आप इमीडिएटली बताइएगा, फिर से मैं चेक कर लूंगी। सो यहाँ पर एक एग्जाम्पल ट्रेसिंग का बता रहे थे, अगर प्रीवियसली आपने नहीं सुन पाया हो तो एक एग्जाम्पल दे रहे थे कि एक अगर आपको कोई भी डिजाइन बनानी है तो आपको जिस भी सरफेस पर वो डिजाइन चाहिए, चाहे वो किसी कपड़े के ऊपर चाहिए, चाहे वो किसी लाइक पेपर के ऊपर चाहिए, जिसके भी ऊपर चाहिए, आप उसको रखते हैं, उसके ऊपर कार्बन पेपर रखते हैं और उसके ऊपर अपनी डिजाइन रखते हैं और पेंसिल से लेकर के उस डिजाइन के चारों ओर जहां जहां डिजाइन बनी होती है उसके अलोंग अपनी पेंसिल को मूव करते हैं। उससे क्या होता है, वो पूरी डिजाइन जो होती है वो उस बेस के ऊपर कॉपी हो जाती है, उस पेपर या उस कपड़े के ऊपर कॉपी हो जाती है। ये ट्रेसिंग ऑपरेशन हम लोग डे टू डे लाइफ में बहुत बार करते हैं। ये आप बचपन में सभी ने किया होगा, अगर आप नहीं करते। बिल्कुल यही काम यहाँ पे बताया जा रहा है डिजिटाइजेशन में। ओके, सो यहाँ पर डिजाइन कोई भी नहीं होती, यहाँ पर डिजाइन तीन ब्रॉड कैटेगरी में होती है। वो तीन कैटेगरी क्या है? दे आर पॉइंट, लाइन एंड पॉलीगन। ठीक है, तो सबसे पहला शुरुआत जब भी हम ऑन स्क्रीन डिजिटाइजेशन करते हैं, फर्स्ट स्टेप क्या होता है? फर्स्ट स्टेप होता है हम उसकी शेप फाइल्स बनाते हैं। शेप फाइल कैसे दिखती है? Shape file looks like this. NYC census block .dbf.prj.sbn.sbx.shp. Okay. Among them, the important one are .shp, which is for the geometry or the shape. .sbx for indexing purpose. .dbf for D-base table, that is attribute data. PRJ for the projection. Okay, so this is how the very first step of digitization starts. That first thing is we need to create a shapefile. When you create a shapefile, just wait. So now I want to create a new shapefile. I'm showing this thing in the ArcGIS. So if I want to create a new shapefile, I will open the Arc catalog, go to the new, go to the shapefile. Okay, and in the shapefile, when I select the shapefile, I have to give the name of that one. Like suppose if I give the name tree, after that you have to select the type. Okay, so there are three types: point, line, polygon. Although in this one there is multi-point, multi-patch. Most of the time we take any three: point, line, polygon. This multi-point is used, like I was giving you the example of forest earlier, that if a forest is represented by trees instead of polygon, in that case, multi-point data type will be taken. There will be different forest, and each of the forest will be represented by multiple points. So in that case, this multi-point, multi-patch thing is taken. But here we will prefer to take any three: point, line, or polygon. This one is the general one. So when you create a shapefile, you need to give the name, you need to give the feature type, that is point, line, or polygon. Thereafter, you have to select the coordinate system. So as you know, there are two types of coordinate system. You can go for. So there are two options over here, as you can see. There can be GCS, Geographic Coordinate System, or Projected Coordinate System. So whichever coordinate system, like whatever is the base map coordinate system, you have to select according to that one only. Okay. So this is how you will set the coordinate system of the shapefile. And the whole shapefile will get created. Okay. Now, if I see this one on the arc map, you can see that there is a file of tree over here. Okay. In digitization, the first step is creation of a shapefile. For a point or several points like tree, school, religious places, all these entities will be represented by a point. So shapefile will be created for each entity. Okay. Each shapefile will represent one and only one entity. Each attribute table will represent only one entity. Multiple features will be there, but there will be only one entity. What will be the entity? It can be tree, it can be school, it can be religious places, anything. Then for the line, like there can be road, there can be railway line. Okay. These things will be represented by a line. And finally, for the polygon or area, anything that comes in a form of a polygon, like river, like forest, like urban settlement, everything will be represented by a polygon. So first step is selection of a shapefile, or instead of selection, the better word is creation of a shapefile. In the very first step, we have to create a shapefile. And thereafter, once the shapefile is created, the next step is we have to start the digitization. Okay. How this digitization is done, like for a point, some of the elements have already been digitized. I will show you on the screen. As you can see that some of the trees are already digitized over here. So they are appearing over here in a green point. Okay, am I audible?
Yes, ma'am.
Someone please confirm. Am I audible?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Ma'am.
So as you can see on the screen, that the trees are represented by a green color and how these trees are created. First of all, I have to identify where the trees are located on the map. So I am zooming in and you can find the green color points over here. So these all are the trees. So in the editor, we have to start editing. We have to start digitization. Okay. So there are in different software, the process will might be, the option will be a little bit different, but the whole procedure will be same. So now I have taken the tree and I will just press my button, cursor button, one. So on each of the tree, I'm just marking one of the point. Okay. So I'm just clicking one time and automatically these points are getting marked over here like this. This is how the point digitization will take place. Okay. Next one is about the line digitization. Like suppose I want to digitize this small road, not the complete road. So whenever digitization start, the digitization of a point is very simple. But when you start doing the digitization of line, you have to take a little bit care. Okay. So first of all, the very first point is marked. The first and the last point of the row of a line is called node, and the intermediate points are called vertices. Okay. In different software, this term may get varied. In different literature or in different book, these terms may get varied. Okay, there is a variation, but you can in some places it is simply a point, in some places it is simply a coordinates, in some of the places it is nodes and vertices. So you must know all these terms. Right now, as you can see on the screen, that I have this cross here. Okay, and I'm going to start to digitize this road. Okay, so I am placing my first point, I have clicked, and then what I will do, first, I need to zoom in properly. Whenever digitization is performed, it must be zoomed in properly. Now, you can see that there is a little bit curve. So whenever there is a curve, larger number of points are taken. And every time the previous point is get connected to the next point by a straight line. Okay, as you can see on the screen, whenever I am clicking on any of the point, it is automatically getting connected by the previous point through a straight line like this. Okay, in raster data, there is an issue of width over here. Okay, so that's why the positional accuracy matters over here. When you are doing the vectorization from this raster data, this digitization is nothing but the creation of a vector data from the raster data set. Okay, and whenever you are performing such type of conversion, there will be an error. Like as you can see on the screen, that this road is not shown by a line. It has some width, isn't it? It is having some width. So when I am doing the digitization, I have to make sure that I am doing the digitization properly, but still, since the width of this road on the map is of several pixels, and what I am doing when I am doing the digitization, I am using just a single point. So there will be inherent errors when you are doing such type of conversion. So let's see, the digitization process will be carried out like this way. Okay, continuously we have to do the digitization. It will take some time, that's why I'm moving it forward. So when you yourself perform the digitization, always take a proper zoom level. Here I'm doing it quickly, that's why I'm not zooming in properly. So whenever we used to check the output of digitization, we always zoom. We always do a zoom in because only then you can find whether the digitization has took place correctly or not. I am doing the digitization of NH30. That's it. So this digitization of road is completed. So when you are doing a digitization of a line, every time each of the vertex will get connected to the next consecutive vertex by a straight line. The number of points that are marked in this process depends upon the shape. If the shape is simple, if the shape is straight, lesser number of points will be marked. If the shape is complex, if there is a curve, in that case, larger number of points are marked in order to preserve that thing. As you have seen that the points are getting connected by a straight line. That's why when there is a curve, larger number of points will get marked so that it will get properly captured in the data set. Okay, so this is how the line digitization have took place. I will show you another example of a polygon. Okay. Okay, now I will take one small polygon because it will take a lot of time. I have done the digitization of this Ganga and Yamuna river already. Straight. Is there any issue of audio? Somebody has sent something in the chat.
Ma'am,
Yes.
what is the best way to detach a circle? If I use the line, it's more like look like a polygon.
Okay. Wait a minute. Just wait for a minute. There's some problem. There's some issue. Okay. So if I want to do the digitization of a polygon, I have added another river. There was some problem earlier. So what again, I will do the digitization of the boundary. And now you can see that here the first and the last vertex, okay, first and the last vertex are automatically connected over here. In the example of a line, the present vertex and the previous vertex were connected by a straight line, but here all the vertices are connected, means each of the vertex is connected with the next consecutive by the vertex by a straight line, but first and the last are also connected. So this is how we will do the digitization of a polygon in this way. Like this. So I have extracted a water body in this manner. Now there was a question that if there is some circle or some rectangle or some ellipsoid, there are some of the options that are available in the software. Like in this software, in the ArcGIS software, I have the option of circle. Okay. So if I want to create some, suppose there is some circular water body, so I will create a circle like this, and this is how it will get created. A circle, it may be some rectangle, it may be some ellipse. Okay. So these are the options are available in the software. With the help of that, you can create a circle. But if the option is not available with the software, in that case, you have to perform the digitization in the same way that you have done earlier. Okay. So you have to check it the same thing for the software. So this is all about the digitization process, that how we are extracting different objects. Okay. So there was a base map. You can do the digitization on that one. If the base map is, you know, many times what happens, instead of taking the base map, we can take some of the image. Okay. We can select any of the image like this way, and we can perform the digitization of the same thing on the image also. Like suppose if I want to digitize the water body, the river Ganga or river Yamuna over here, in this case, the map will provide quite old data because the map was surveyed in the year 2009 or 8. Okay. But the river has got changed a lot during 1 decade time. So if I want to do the digitization, instead of taking map, I can use this image in the backdrop and perform the digitization in the similar manner. So this is about the digitization process through which the features can get extracted. It is a very time-taking process. Like you can see the NYC data. You can see this NYC data that there is a very dense streets over here. There is a dense street and everything has got digitized, and now you can perform any of the operation over here. The digitization will take time, and it's not just about the way I have extracted the feature. After that, will be one more step of adding of attribute. Okay, we need to associate the attribute data with that one, and thereafter you can perform any of the analysis. Therefore, this is a general statement that when there is a GIS project, a very large portion, 50 to 60% time of any research will be devoted to the data creation, database creation only. Because as you can see, I have shown you the digitization process. It is not a very simple process. It is a very labor intensive process. It will take a lot of time. If you have a raster map or if you have a raster image, whatever you are using in the backdrop, you have to perform the digitization on that one. So this whole process of all the points, line, polygons, you have to complete this procedure. Okay. Now, there are modes of digitization. There are two modes of digitization: point mode of digitization and stream mode of digitization. The way I have performed the digitization, or you have done the digitization in the laboratory, it is called the point mode of digitization. In point mode of digitization, the operator has to press the cursor every time when he or she wants to mark any of the sample point. Okay, this is called the point mode of digitization. In point mode of digitization, the operator has to press the button manually every time. Now, another option can be a stream mode of digitization. In mode of digitization, instead of marking point every time by pressing the cursor or the mouse button, instead of using that, there will be some sampling frequency, like after every 0.4 second, a point will be marked. So I will show you the example of that one. Just wait for a minute, there's some issues. Yes, so in this one, if I take a free hand, okay, and suppose I want to digitize some river, like this portion of river Ganga. So I will just click on this one and just move my cursor in a freehand manner. Okay, just like the way I move my pen or a pencil, I am tracing this whole. Yes.
Ma'am, there is at least 15 to 20-second lag, ma'am, in video.
Okay. Okay, so leave it. I have already shown you the rest of the details. I will show this thing in some other time. Because if there is a lag, it will not be possible for you to understand what I am telling. Okay. Just wait, the screen will appear.
Ma'am, it's coming now.
Okay. So right now I have opened modes of digitizer. There are two modes: point mode, stream mode. I was trying to show you the stream mode over there. In that case, you just have to move the cursor and the point will get sampled automatically based upon the sampling frequency. This is called the stream mode of digitization. There are two modes of digitization: point mode of digitization and stream mode of digitization. In point mode digitization, the operator must press a button to sample each point. Person digitizing decides where to place each individual point, such as to most accurately represent the line within the accepted tolerances of the digitizer. The points are placed closer together where the line is most complex and where the line changes direction. Points are placed further apart where the line is less complex or made up of straight line segments. Okay. Next, stream mode. Points are automatically sampled at a fixed time, one each second, and it is not appropriate when digitizing point feature because it is usually not possible to find and locate point at a uniform rate. Okay. So point mode, stream mode में अंतर समझ में आ गया होगा. जो डिजिटाइजेशन हम लोग करते हैं वो पॉइंट मोड होता है, जिसमें हर एक बार माउस के बटन को प्रेस करके सैंपल कलेक्ट किए जाते हैं. दूसरा ऑप्शन होता है स्ट्रीम मोड डिजिटाइजेशन का, इसमें ऑटोमेटिकली सेट किया जाता है. इसमें एक चीज इंपॉर्टेंट होती है, वो है सैम्पलिंग फ्रीक्वेंसी, कितनी देर में पॉइंट मार्क होगा. अगर सैम्पलिंग फ्रीक्वेंसी बहुत कम कर दी जाए, अगर बहुत लाइक सपोज 0.01 सेकेंड पर हम पॉइंट मार्क करवाने लग जाए, तो उसमें बहुत ज़्यादा लार्ज नंबर ऑफ पॉइंट्स मार्क हो जाएंगे रिडंडेंट पॉइंट, अगर आपको याद होगा हम लोग ने जनरलाइजेशन पढ़ा था जिसमें सिंप्लीफिकेशन था। ओके, सो सिंप्लीफिकेशन में हम लोगों ने देखा था कि किस तरीके से वीड आउट किया जाता है जिससे कि नंबर ऑफ पॉइंट्स कम हो जाए किसी भी फीचर में, जिससे उसका स्टोरेज स्पेस कम लगे। स्ट्रीम मोड ऑफ डिजिटाइजेशन में अगर फ्रीक्वेंसी बहुत लो पे सेट है, मतलब बहुत जल्दी डेटा कलेक्ट हो रहा है, ठीक है, उस केस में ओवर सैम्पलिंग हो जाएगी, ज्यादा पॉइंट लग जाएंगे। इसी तरीके से अगर सैम्पलिंग फ्रीक्वेंसी बहुत लंबी रख दी जाए, बहुत स्लो सैम्पलिंग कराई जाए, सपोज 2 सेकेंड में एक पॉइंट मार्क हो रहा है, तो उसमें ऑपरेटर अपना कर्सर मूव करता जाएगा लेकिन उसके पैरेलली पॉइंट नहीं मार्क होंगे, अंडर सैम्पलिंग हो जाएगी और करेक्ट शेप जो है, करेक्ट डिटेल जो है वो कैप्चर नहीं हो पाएगा उस केस में। इसका एक एग्जांपल यहाँ स्क्रीन पर दिया हुआ है कि किस तरीके से पॉइंट और लाइन मोड डिजिटाइजेशन किया जाता है। पॉइंट मोड में हम नंबर ऑफ पॉइंट्स बढ़ा देते हैं, जहां कहीं भी कर्व आता है, कॉम्प्लेक्स कर्व्स आते हैं या डायरेक्शनल चेंज होते हैं। स्ट्रीम मोड ऑफ डिजिटाइजेशन में हम स्पीड घटा देते हैं, हम स्लोली मूव करते हैं जहां कहीं भी कॉम्प्लेक्स कर्व आता है। स्लो मूव करने से नंबर ऑफ पॉइंट्स जो है उस जगह पर ज्यादा सैंपल हो जाएंगे। ठीक है, तो ये पॉइंट मोड और स्ट्रीम मोड ऑफ डिजिटाइजेशन हो गया। नेक्स्ट, डिजिटाइजेशन के जो इश्यूज हैं उनके बारे में भी हम लोग देखेंगे आगे चल के। अभी 10 मिनट्स का ब्रेक दे रहे हैं और 10 मिनट्स के बाद में वापस से क्लास स्टार्ट करते हैं इसी पॉइंट से। Okay, so let's start the class again. So previously we were discussing about the digitization process. Okay, so in that you have just seen how the digitization is performed and how the layers or how the different features get extracted from the raster data. Okay, if you have a map, this is how you will extract the features, and later on you can perform any type of analysis like I have shown you the distance based proximity analysis on that streets, NYC streets. So similarly, the other operation could get performed with the help of vector data. So there are some advantages and disadvantages in this system. Okay. So first, if you see the advantage, the learning of this digitization is very easy. Anyone with some days of training, they can easily perform the digitization. That's why in our country, a lot of work is coming from the foreign countries for the digitization. This digitization is a labor intensive process. It will take a lot of time, a lot of labor, and that's why it get outsourced to our country. And a lot of GIS companies are doing this digitization work. Many times students used to ask that when we have a raster data, can't we do the automatic digitization of everything? The answer is yes. Yes, we can do the automatic digitization. But the problem is that when you perform the automatic digitization, several times the software is not able to recognize the things correctly. Like if you check the map, no, the map is very complicated. Several times you need to, like as I have opened this map, okay, so you need to interpret so many things on this map by yourself, or you will take the help of Google Earth, some sentinel image or something else to recognize the things, because they are not always very much clear on the map. It is not a complete automatic process. The human interpretation, the human intelligence is desired in the process of digitization. That's why, although automatic digitization is possible, but after the digitization, post digitization, there is a lot of editing, there's a lot of correction that need to be made. That's why we always prefer the manual digitization, so that the digitization process will be more accurate. Another thing is, many times the source data is not very clean. Like the map that we are digitizing, it may have some fold, some stain, some marking on that one. If you perform the automatic digitization, that thing will also get added up. As a human being, we are able to distinguish whether it is a stain or whether there is some symbol over there. Okay? So that's why manual digitization or human intelligence is always important in doing the digitization. Okay. Next, attribute information can be added during the digitizing process. High accuracy can be achieved through manual digitizing. That is, there is usually no loss of accuracy compared to the source map. Then don't do this thing while the lecture